In this recording, we're going to learn about conditional probability. And that's the probability of one event occurring given that another event has already occurred. So there's a formula here that we will know about, but in addition to knowing the formula, as it says here, when using two-way tables, it may be easier not to use the formula. Okay, so we're going to look at a way to do these with a two-way table, and I think it'll be pretty intuitive for you when we get to that. We need to make one small change here. Okay, please make this 11-2. Okay, so we're going to revisit this frequency table that we saw having to do with if you go to college or not and your gender. I think you're able to answer question 1A and B, so please do that. Then play the recording when you're ready. Okay, so hopefully you did this, and the probability of being female is all the way down here at the bottom. We're not counting whether they went to college or not. That's 22 out of 52. We could simplify that. We don't have to, but 11 out of 26. Probability of going to college, well, that would be way over here, the 29 out of 52. Now, this is the new material here. The given that they're female, what's the probability of going to college? Okay, so this is a conditional probability, and the notation here, you're going to want to make note of. The notation here is a line, a vertical line. So this is read, the probability of going to college given that they're female. Okay, so that's those words right there. So let's complete this Venn diagram to try to make sense out of this. Okay, so first off, how many females are there out here that are not going to college at all? And again, we can slide this up a tiny bit and see those. Okay, so those would be the people in the female area. They're not going to college. In the overlap, we have all our females that are going to college. So again, that's this number here, 13. And then over here, we have our people that are going to college that are not female. So the 16 males. Okay. And so if we're trying to find the probability of going to college, given that a person selected is female, what are we looking at here? Well, we're only looking at, let me get my nice highlighter pen. We're only going to consider in this circle, because it said given that a person is female. So you're not looking anywhere else. And if so, what's the probability of them going to college? Well, that's going to be right here, right? So those 13 out of, well, I'm not counting everybody. I'm only going to count inside the circle. So 13 out of the 22. Okay, so we'll go through that one more time because this is a huge idea. We're only considering the females because it said given they're a female. And so we're considering 22 people. And we want the ones that are going to college. So 13 out of 22. Where can we see that in the table? Well, we've got that here. We're only looking at the females because it said given that they're female. So we'd be looking right in here. What's the probability of them going to college? And that would be right here. So 13 out of 22. And then not to belabor this question too much, but I want you to see where that formula that we looked up above, right here, this formula, how this connects to the answer that we just got. So again, the probability of going to college given that a person selected is female can be found by the probability of going to college and being female divided by the probability of just being female. And of course, we would have in the numerator probability of going to college and being female. Well, that's the 13 out of 52. And the probability of being female only is a big old complex fraction here. Probability of female only is being 22 out of 52. And the way we simplify this complex fraction is we get rid of these denominators of 52. So I'm just going to multiply by 52 over 1. Because as long as I'm multiplying the numerator and denominator by 52, I'm really just multiplying by 1, right? So these 52s divide out, and I end up with 13 over 22. Same thing. Okay? So, which is more likely to happen? A person picked at random will be going to college given that they're a male. There's our notation. Or that a person will be a male given that they're going to a college. Why don't you pause the recording, do what you can with this, and then play the recording to get some help or see the answer. Okay, so this first one, probability that they're going to college given that they're male. We're only looking at the males, looking right here, and the probability of going to college would be 16 out of 30. Of course, we can simplify that, or we can also make it a percent, so it works out to be 53%. And now the probability that they are male given that they're going to college. These are not saying the same thing. It's looking at a different group of students. Okay? Given that they're going to college is right in here. So looking at all these, so out of just those 29, what's the probability that they're male? 16 out of 29. So you can see that those are not the same thing. They have different denominators, same numerator. This works out to be a slightly different percent. It's 55%. And so it says, which is more likely, and we could state that it is more likely that a person picked at random will be a male, given that they're going to college. Okay, and a little English thing here. Our English people among us would want us to say that he or she is going to college. We should not use the plural here because we're only speaking about a person. Even though this question is written that way, we'll be correct in our answer at least, okay? Cool. Let's look at question 2. A survey was taken to examine the relationship between hair color and eye color. All right. We want to find the probability the person picked had brown eyes given that he or she had blonde hair, and then find the probability that the person had red hair given that he or she had green eyes. Please work these out and play the recording when you're ready. Okay, so let's tackle the first one in a blue pen. Given that he or she had blonde hair, so we're just considering all of these right here. What's the probability that the person had brown eyes? So it's 0.10 divided by 0.35. And when you divide that out, it works out to be 0.29. If you did not work out the second one, give that one a try. Maybe you have a strategy now that you could use. Okay, so hopefully you worked out the second one. Given that they have green eyes, so we're considering right here, all the green-eyed people. And, okay, of those, what's the probability that someone has red hair? So, red hair out of the total green-eyed people, so that would be 0.15 divided by 0.25. When you work that out, it works out to be 0.6 exactly. I shouldn't have these wavy equals. Let's get rid of them. Okay, and our last example that has to do with conditional probability is this. This is from an AP Stat multiple choice question, so it's a rigorous question. I'm going to show you two different ways. We're going to solve it with a hypothetical 1000 table, and we're also going to solve it with our formula. So let's try first the hypothetical 1000 table. Okay, so we're going to create a two-way table, which is a 4x4 grid. And now we need to consider, well, what are our variables here? Well, I want you to read through this and determine what are the two variables that we'll put in the top. Obviously, this is going to be total, right? We know that's going to be total and total. But read and then think about what goes here, and then play the recording. Okay, there's a couple ways to set this up. I went with something like stops working. And then maybe doesn't stop working. And then along the right side, damaged in delivery, not damaged in delivery. All right, well, now here becomes the challenge. We know we're going to have 1,000 hypothetical machines here, microwaves. You could put 100, as long as you don't end up with any decimal, because we can't have decimal amount of microwaves. Well, let's take each phrase here and see if we can populate this table. First, the probability that will stop working in less than 2 years is 0.05. So 5%, right? So 5% of the machines will stop working. So 5% of 100 would be 5. Out of 1,000, it's 50. The probability that a new microwave is damaged during delivery and stops working, so both, is 0.04. It has to have both. So again, that's 4%, so 40 out of 1,000. Okay, so that was an and. The probability that the new microwave is damaged during delivery is 10%. So that'd be 100, right, out of 1,000. So is damaged altogether would be 100. And now we have enough information to fill in all the rest. Go ahead and fill in all the rest, then play the recording when you're ready. Okay, so hopefully you got your 900 here, your 950 going across, 60 here, 10, and then 810. That doesn't work out, right? 890. All right, let's try that one more time. 10 and 890. All right, we're better. All right, good. So now we need to answer the question. Given that a microwave is damaged during delivery, what's the probability that it stops working in less than 2 years? Answer that question using the probability, it's using the hypothetical 1000 table, just like you did above with this one. Okay, so hopefully you said something like this. Given that is damaged during delivery, so we're working just within this zone right here. What's the probability that it stops working? So 40 out of 100, 40%. Cool. Show you another way, and maybe like that, maybe that all made sense, and I think it does. Hopefully it makes sense for you. I'm going to show you another way, the formula. Because you should have both tools in your toolbox. Okay, our formula for, I'm going to use like stops working and damaged. So I'm going to say the probability of stops working given that it's damaged is the probability of it stops working and is damaged divided by the probability that it's damaged. So that's from our formula. And therefore we have these figures given. So pretend we don't even have the hypothetical 1000 table. We did not create that. Probability that it stops working and is damaged. See if you can pull that information out of this. And also the probability that it's damaged. Then play the recording when you're ready. Okay, so hopefully you found the 0.04 and then the probability that's damaged, 0.1, and of course that works out to be 0.4. Same answer as before. Thanks for watching.